In this presentation, I will be explaining closed loop control of electric drives. Coming to the closed loop control of electric drives. In many applications where a constant speed is required, open loop operation of motors may not be satisfactory. In open loop operation, if the load torque changes, the speed also will be changing. That is, if you are changing the load torque, then the speed gets changed. If it is an open loop control system, control motor. Now in a closed loop system, the speed can be maintained constant by adjusting the motor terminal voltage as the load torque changes. Therefore, we are sensing the load torque, and based on the requirement of the load torque, we are adjusting the voltage applied to the motor. Thereby, the motor torque is made to equal to the torque demanded by the load. That is done by closed loop control. Now, this is the basic block diagram of a closed loop speed control of a motor system, in which here the reference speed is given as the N star, and the actual speed of the motor is sensed using a speed sensor that is fed back, as that is given as a negative feedback signal, and error is taken, and that error is given to a controller. That is, normally it is a speed controller, or it's called the PI controller, and the PI controller output, that is DC, this voltage, that will be used, so that will be controlling the firing angle of the converter, or that will be controlling the converter, and will be and it will be bringing the voltage across the motor to the required value, so that that will be producing, the motor will be producing a load, is a motor torque or the electromagnetic torque that is required by the load. That is in a closed loop control system. This is the basic block diagram of a closed loop control system driving a motor load system. Continuing the closed loop control of a drive system, if an additional load torque is applied to the motor, the speed of the motor momentarily decreases and the speed error increases, which in turn or increases the control voltage. That is, here we are measuring the speed as the load torque demanded by the load is increasing, the speed gets down. Therefore, that speed is sensed here, and that is compared to the reference speed. You want to run the motor at a certain speed, or error increases. As this error increases, the controller output voltage VC also increasing. That will be adjusting the controller in such a way that it will be producing the required voltage across the motor and producing the required motor torque. Therefore, the control signal increases, that is this control signal, this VCC control signal, which is the output of the controller, PI controller, increases the converter output voltage. That is, if it is a control rectifier, the control signal decreases the firing angle and the voltage is increasing. Or if it is a phase control rectifier, or if it is a chopper, it's a DC motor here, input is DC, it will be increasing the duty ratio. By increasing the duty ratio, if the converter is a chopper. If the converter is a chopper, we are increasing the duty ratio. If it is a control rectifier, we are reducing the firing angle so that this voltage is increasing. And increasing the motor armature voltage develops more torque to restore the speed of the motor. Therefore, the motor torque increases, that is, increases the speed of the motor to the required value, N star. Now, the advantage of closed loop operations are, one is that it has got a greater accuracy, improved dynamic response, that is responding at a very faster rate, and stability of operation, stability of the system also increases. Another advantage is that circuit protection can also be provided by using the closed loop system. For there are a lot of advantage of introducing a closed loop system in a motor drive system. Previous slides we have seen the basic control block diagram, closed loop control block diagram of a motor load system, and in this one, this is a current limit control. In current limit control, the control scheme is used to limit the motor and converter currents below a safe limit during the transient operation. During the transient operation, maybe during the starting or during the braking, during all those processes, we want to bring the current to within that limit. Now, coming to this block diagram, here it is given the I star, that is a current reference. This is the current that we want to bring to the actual current of the converter or motor to this value I star. And actual current here, there is a current sensor is there, and there is a threshold logic is there, and this output is given as the actual current. That's a negative feedback. Error of the current is taken, that is given to a controller, say PI controller, and the PI controller controls this converter such that the motor voltage will be changing and the current will be controlling to that value. So this is a motor load system in which the power is being controlled by this converter and based on the controller output. This control scheme is used to limit the motor and the converter current below a safe limit during the transient operation. Feedback loop will be active only when the current value reaches to the set maximum value. We are setting it to a certain maximum value. If the current is reaching to that set maximum value, then only the feedback loop is active. That will be controlled by this one. And the current is brought to less than the set maximum value during this due to this introduction of this feedback loop. Once the current magnitude goes below the maximum value, then the feedback loop becomes inactive. But the feedback loop, in this case, the feedback loop is active only if the current is going above this threshold value. Suppose we are limiting the current by introducing a feedback loop like this one. If the current exceeds that set value again, it again brought to below the set value by action of the feedback loop. Then again the feedback loop will be coming and the current will be brought to the what is the maximum permissible value. This is called current limit controller, in which by this feedback loop will be active once the current is coming into or is more than this threshold value. This explains the closed loop control of the torque. In this block diagram, T star is the reference torque. This is the required torque. And the actual torque is sensed using a torque sensor, and that is fed back. This is the actual torque. This is the reference torque. Error is taken. Torque error is taken. And that torque error is the input to the torque controller. Torque controller, again, as I already told, it is a PI controller. And that torque controller output controls the converter so as to control the voltage, or if it is a current source inverter, the current will be controlling. If it is a voltage source inverter, voltage will be controlling to the motor, and thereby it controls the, or it will be producing the required torque, or it produces the torque required or demanded, or it is as we are setting the certain value. So we are setting a torque to that value, that motor torque will be developing. Therefore, this type of closed loop controls are used in battery powered vehicles, rail cars and electric trains. This type of load torque control, closed loop control of torque is done for this battery powered vehicles, etc. And the driver, as the driver presses the accelerator, what he does is, he is doing reference torque T star is set. It sets the reference torque T star. Though through closed loop control of the torque, the actual motor torque T is compared with the reference torque, and the torque error is given to a torque controller. That is given to a torque controller. Again, that's a PI controller, and the torque controller output controls the converter so as to produce the required voltage and so as to produce the required torque in a way. Therefore, thus motor torque reaches to the reference torque, or motor torque follows the reference torque T star, and the speed of the drive is controlled by putting the pressure onto the accelerator. Therefore, this type of torque control mechanism or closed loop control of the torque is used for the vehicles, electric vehicles like battery powered vehicles or rail cars or electric trains. Therefore, this is the reference torque, and the motor torque is brought to the reference torque by controlling the voltage across the motor. That is, converter controls to produce the voltage to the motor so as to produce the torque to this reference value. In the case of the torque produced by the motor and the load torque, that is related to the dynamic torque J d omega dt, like this one. T minus TL equal to J d omega y dt. That is, the difference in motor torque and load torque will be changing the speed, either maybe accelerating or decelerating. So this is the relation connecting the motor torque, load torque, and speed of the motor. Now coming to the closed loop control of the speed. In closed loop control of speed, there are two loops. One is the inner loop, that is the current loop, and outer loop is the speed loop. Therefore, inner loop, there is a current sensor is the motor current is sensed, and that is given as the actual current. And outer loop, there is a speed sensor is and this is given as the actual speed. Therefore, the reference speed is compared with the actual speed. That is error delta omega m that is produced. A omega m error or speed error is produced. Speed error is the input to the speed controller. Again, it is a PI controller. And the speed controller output, actually that is representing the reference current I star. But in order to limit that current, there is a current limiter is there. Therefore, the speed controller output is given to a current limiter that limits the value of the current. It won't allow the current to go below this value. Therefore, this is a current limiter, and the current limiter output is the actual current. So not actual current, it's a reference current. For this much current is I star, it is I star. For this much current is required, and the actual current is sensed by current sensor, that is given to the negative input, or say negative feedback. For reference current is the actual current is the current error is taken, and the current error is the input to the current controller. Again, it is a PI controller, and the current controller output is given to the converter for controlling the converter, and the converter controls so as to produce the required voltage that's to be applied to the motor, and that is connected to the load. Motor load system is this one. Therefore, this is a two loops are there. Inner loop is the current loop, and outer loop is the speed loop. Now coming to this one, inner current loop is provided to the limit the or controls the converter and motor current to the reference current I star. Therefore, I star is this one. This is the reference current. Now, how can you generate the reference current? The outer loop, the speed omega m, that is actual speed of the motor, is sensed using a speed sensor. Omega m is compared with a reference speed omega m star, and the error is given to a speed controller. Again, it is a PI controller. A speed controller, that's a PI controller, and the speed controller output is given to a current limiter block. That is a current limiter block. And the output of this current limiter, that is the reference current I star. For this much current is required, that is I star, and the actual motor current is I is compared with the reference current I star, and that is given to another controller, current controller. It is again a PI controller. Current error is given to a current controller, a PI controller, and the current controller output that gives a signal that will be used to control the converter such that motor runs at reference speed omega m star. The motor will be running at the speed omega star. That is the reference speed. You want to run the motor at omega m star. That's maybe 1500. You want to run the motor to 1500 means that it is sensing the speed, and that is finally the motor will be running to this 1500. That is the closed loop control of speed control. That is closed loop control of the speed, in which inner loop is current loop and outer loop is speed.